Today we are going to spend another day solving our three variable matrices. So we're going to start off by doing it the way that we talked about yesterday. When I look at my equations, what I would pick as the easiest variable would be x in the first one. So we're going to write that equation 2 times. And then we're going to write the other equations below it. So we've got a negative x, a 5y, 3z equals 2. And then our other equation, 3x minus 2y minus 4z is equal to 18. Alright, so what we have right now is our two three-variable equations set up to be eliminated. I want you to press pause and I want you to try to remember how to solve your three-variable equation by hand. So press pause. Alright, let's see how you did. Remember, we chose the x's, and the x's were already canceling in the first equation, and we got a negative y and a positive 1z is equal to a negative 6. So there's the first two variable equation we have. When we go to the second one, you may have been tempted to eliminate the y's or the z's, but remember, you have to eliminate the same variable. So we multiply the top row by a negative 3, we get our x's to cancel, and then our equation ends up being 16y plus 2z equals 42. We take those two equations with the x's gone, and we use our elimination method with the y's and the z's. I chose to eliminate the z's. This was a positive 2, so I made this a negative 2, and I found that y was 3. When we go to find our z, because we have a two-variable equation, we want to make sure that we use one of these two from the system that we just solved, and we're able to find that z is negative 3. Then I go back to any of the three originals. I chose the one that I wrote twice, and I plugged in the 3 that I solved for y, and I plugged in the negative 3 that I found for z, and our solution is x is 4, so therefore our solution to the system is 4, 3, negative 3. Now, what we're going to do is we're going to look at a quicker way how to do it without doing it by hand. You still have to know how to do it by hand because remember, part 1 of your test will be solving a three-variable system algebraically by hand. Inverses are not allowed. And that's our quicker way to do it, is to use the inverses. What you want to do is you first want to make sure all variables are lined up. So just like when you're using the elimination method, the x's all go first, the y's all go second, the z's all go third. And what we're going to do is we're going to take those coefficients and put them into a matrix. So we have all the x coefficients are going to be in the first column, all the y's are going to be in the second column, all the z's are going to be in the third column. So when we look at the x coefficients, we have a 1, a negative 1, and a positive 3. When you look at your y coefficients, you've got a negative 6, 5, negative 2, and your z's are a negative 2, a 3, and a negative 4. What we're going to do is we are trying to find our x, our y, and our z. Then we look at the solution set. What are our equations equal to? Well, the first equation was equal to a negative 8. The second was equal to 2, and the third one was equal to 18. This first one is going to be our A matrix. The second piece is going to be our x, what we're solving for, and our solution set is going to be our B. So we've got AX is equal to B. So A times X is equal to B. If I want to find X, if I want to find that solution set, I do that by finding the to get rid of it, I have to move it using the inverse. So to find our solution, it's x is equal to the inverse of A times B. And we're going to be able to do this all on our calculator. And the order does matter. So if you don't have your calculator out already, get out your calculator. So press pause and get out your calculator. Alright, now that we have our matrices set up, we need to enter them into our calculator. And we haven't talked about matrices in our calculator since the first chapter. So remember, matrix is right above the x to the negative first, the inverse button. So we hit second, x to the negative first. We want to enter this into matrix 1. So you have the arrow to the right. We want to edit. And we want a 3 by 3 matrix. And I've already entered in my numbers 1, negative 6, negative 2, negative 1, 3, 5, 3, 3, negative 2, negative 4. Press pause, enter all of your data in. Once you have entered it in, now we're going to go to our second one. So to edit that one, we have to do second x to the negative first again. We are not going to enter variables in, we're going to enter the solution set in. So we go down to 2 and we're going to edit number 2. And this is a 3 by 1 matrix. Oops, I edited the first one. Arrow down to number 2. We've got a 3 by 1, so we entered a negative 8, a 2, and an 18. And remember, to get this unknown, our unknown variables, our x, our y, and our z, the way this is set up is the inverse of a times b. So we're going to go back to our home screen, and to get a on the home screen, we have to do that second inverse again. Instead of editing, we want to use it, so we want to use 1, so you can either hit 1 or enter. But we want the inverse of 1, so we hit that to the negative first, and then we're going to multiply that by b. You can hit multiplication, you don't have to, so we go to second inverse again, go down to number 2, because we want to use b. So our unknown, our x is equal to the inverse of a times b. We hit enter, and it tells us that x is equal to 4, 3, negative 3. This is representing our x matrix. So this is saying x, y, z is equal to 4, 3, negative 3. Which, when we did this by hand, you see that we got exactly the same answer as we did using our calculator. The one thing that you want to be careful about is when you do use your calculator and you get this as your answer, make sure that you write it the proper form. So it should be 4, 3, negative 3. Our x is 4, our y is 3, and our z is a negative 3. Alright, so let's do some practice on finding the inverses in our calculator, because this is new. We didn't do inverses when we talked earlier in the year about matrices. First thing we want to do is enter in matrix A into our calculator. So second x to the negative first again, we want to edit. And we now have a 2 by 2 matrix. And our values are 3, 1, 4, 2. So we enter our values in. We want to go make sure that we go back to the home screen. If we want to find the inverse of A, we've got to go to that second x to the negative first, 1. This is the inverse button. And we hit that. The calculator does all the hard work for us. 1, a negative 1/2, a negative 2, and 3/2. So what I want you to do is try to do B on your own, enter in your matrix, and then do the inverse. Now just because this is called B doesn't mean that you have to put it in matrix B. I could put that in A, I could put that in B, I could put that in C, it doesn't matter. Alright, for your B inverse, you should have found negative 2, negative 3, 1, negative 3, negative 3, 1, negative 2, negative 4, 1. If you did not get that as your B inverse, go back and make sure that you plugged your numbers in correctly. A lot of times you'll forget a negative with the number, or you hit a number twice. So just make sure that every single time you're entering those values in, that you're entering them in correctly. Alright, we're going to go back to solving our inverse matrices. First thing we want to do is make sure, again, our x's are lined up, our y's are lined up, and our z's are lined up. The first piece is entering in the coefficients of the x, y's, and z's. You multiply that by the unknown variables x, y, z, and you set that equal to the solution set of 18, 0, 3. And remember, this is equal to your A, this is your X, and this is your B. When we want to solve for our unknown x's, x is equal to the inverse of A times B. So what we've got to do at this point is get this information into the calculator. So again, we do second, x to the negative first. We want to edit, so we arrow to the right, hit enter, enter all of your values in. Again, if you need to, press pause, take a second, get all those values in. It's really important that you're actually going through the motions on your own on your calculator so that you have that kind of muscle memory so that when it comes to the test, you remember how to do it. Just looking at it and hearing me isn't enough. You actually have to go through the steps on your own. Then we want to put in the next set of data. So we're going to edit again. We go down to our second one, and we've got a 3 by 1, which is 18, 0, and 3. We go back to our home screen, and I can even, instead of having to go through all that mess of going second whatever, I can go second enter, and 2 ago I actually solved for x, so I can hit enter again. Or I can go the long way and I can go and do x inverse times b, doesn't matter. And I get that my x, y, z, my calculator tells me is 6, 0, negative 3. So it tells me that my x is 6, my y is 0, and my z is negative 3. So my solution, always write it in coordinate form, is 6, 0, negative 3. Alright, we have one last one. So what I want you to do is try the last one all on your own, set up your matrices, enter it in your calculator, and see if you can solve for x, y, and z. Press pause and then check it when you are finished. Alright, the most important part with this last problem was that you had to make sure that you rearranged your variables first. Remember, all x's must be lined up, all y's, and all z's. And these are all intermixed, so you had to rearrange the equations. We didn't go to the other side of the equal sign, so the 2x stays as 2, the z stays as a positive 1, the 3y stays as a positive 3y. Don't change it to the opposite unless you're going to the other side of the equal sign. So the first thing we do is rearrange our variables so that the x's, y's, and z's are lined up. Then we take the coefficients, put those into matrix A. Our variables we're solving for, x, y, and z, are our x matrix, and then our solution set of a negative 1, 1, and negative 2. Here's our A, our x, and our b. Our solution we find by taking the inverse of A and multiplying it by b. And when you do that in your calculator, you get 2, negative 1, negative 2. So your solution is the coordinates 2, negative 1, negative 2. Alright, what we're going to do tomorrow in class is apply this to word problems, which will be on your test. But for today, we are done.